There's a comet out there that shouldn't exist, a silent wanderer from beyond our solar system. Cold, precise, defiant. Its name is 3I Atlas. And what makes it terrifying is not what we see, but what we don't. On October 14th, 2025, NASA's TESS satellite released a dataset of more than 9,000 frames, each one carefully stacked and analyzed. The target? A faint interstellar object crossing the outer edge of our planetary family. The result: no dust, no coma, no tail. Nothing that should define a comet. Think about that. An object supposedly made of ice and rock, heated by the sun, and yet it refuses to melt. It reflects light like a star, not like a comet. It moves like a comet, but behaves like something pretending to be one. In a universe ruled by physics, 3I Atlas is breaking the rules. And here's the part that makes scientists uneasy. While JWST reported water vapor and carbon dioxide spewing from its surface, TESS saw a point of light as sharp as a distant sun. No haze, no plume. Two eyes looking at the same object and seeing two different realities. Coincidence? Instrumental noise? Or a sign that this visitor isn't what we think it is? Some whisper that the data was too clean, that certain readings vanished before reaching the public archive. That the Psyche spacecraft, positioned perfectly for a side glance, captured something it wasn't supposed to. But as always, the silence speaks louder than denial. Because somewhere between the numbers, in the gaps no one explains, a pattern is emerging. A pattern that challenges everything we know about comets, about interstellar visitors, about the limits of what's natural. So tonight, we follow the evidence, all of it, from the missing tail to the missing data, from the dust that never was to the questions that won't die. Stay with me. What you're about to hear might change the way you look at the sky forever. Chapter 1. TESS and the Guest Without a Tail. Picture this. A world wrapped in darkness, thousands of telescopes piercing the void, all pointed at a faint wanderer, slicing through the edge of our solar system. For months, astronomers had tracked it, an interstellar object moving too fast, too precise, too alien. Its name, 3I Atlas. The third confirmed interstellar visitor after Oumuamua and Borisov. But from the very beginning, something was wrong. On October 14th, 2025, NASA's TESS satellite released a dataset no one expected. More than 9,000 frames, each stacked using co-adding, a method where faint signals combine to reveal the unseen. If a single grain of dust had shimmered near the object, the stack would have revealed it. But it didn't. What appeared instead was a perfect point of light. No halo, no coma, no trace of dust. Even the radial brightness profile matched that of a distant star. Steep, symmetrical, featureless. A comet is supposed to breathe, to shed vapor and dust when sunlight hits its frozen surface. But Atlas didn't breathe. It stayed still, sharp and cold, as if carved from glass that refused to melt. Astronomers rechecked the instruments. They recalibrated filters, reprocessed images, compared background stars. The result was always the same: no tail. To a scientist, silence can be terrifying. It means either the instruments failed or the universe just rewrote its rules. TESS was built to detect exoplanet transits, to measure starlight down to 20 parts per million. If it could see the shadow of a moon across a star hundreds of light years away, it could certainly see a comet's glow. Yet for Atlas, the numbers refused to move. Some called it an observational glitch. Others whispered about non-reflective materials, surfaces that absorb light like stealth technology. A few even suggested engineered symmetry, a design meant to cancel diffusion patterns. Because when you zoom in on 3I Atlas, its light curve is too clean, too stable. Comets rotate. They flicker as sunlight shifts across their uneven surfaces. Atlas does none of that. It shines like a miniature beacon, steady, deliberate, unblinking. At its distance from the sun, it should have warmed enough to vaporize ice, releasing gases and dust. Instead, its temperature remained inexplicably low, as if something were regulating it. No known physics explains that, unless the object is made of material unknown to our chemistry, or cloaked in a thin, insulating layer, a vacuum shell. Every scientist who published on Atlas used the same word, anomalous, a word that means wrong without daring to say impossible. After the TESS release, independent teams around the world reanalyzed the data. ESO's Very Large Telescope in Chile, JAXA's Subaru Array in Hawaii. Every analysis converged on the same truth. Atlas is too compact, too pure, not a debris swarm or cloud, but a single, reflective body. Then came the contradiction. While TESS saw nothing but a clean point of light, JWST detected spectral lines of water vapor and carbon dioxide. Two instruments, observing within days, reporting two incompatible realities. One must be wrong, or both are right, and something far stranger is happening. In online discussions, a new term began circulating: ghost comet. A body that emits gas but no visible dust, energy without mass, a glow without matter. Such a phenomenon would demand chemical processes never seen before, perhaps a reaction chamber sealed within its own crust. Natural? Unlikely. Simple? Never. The pattern continued, slight fluctuations in brightness repeating every 22.4 hours, too regular for noise, too weak for rotation. Could it be signal interference? Coincidence? Maybe. But the interval matched the orbital period of a hypothetical object, one solar radius above the sun's surface, where probes send magnetic pings. So what was echoing that rhythm out near Jupiter's orbit? The official reports ignored it. Unofficially, analysts began calling it the Atlas Pulse. When the TESS data went public, amateur astronomers restacked the frames. They confirmed the point source and noticed missing files in the archive. Numbering gaps, clipped metadata. NASA called it compression. Yet those missing frames aligned with Atlas's perihelion, its closest pass to the sun. Curious timing. Inside research networks, quiet emails circulated. If a comet crosses perihelion without shedding, it's not a comet. It's something else. But no one wanted to write that sentence. Data can be as political as power. To admit an anomaly is to invite chaos. And institutions don't like chaos. So the papers called it non-standard behavior, unexpected low-activity state, unresolved nucleus, words designed to hide the wound. But among those who looked deeper, another question emerged. If Atlas is dead, why does it shine so perfectly? Rocks don't emit light. Unless the light isn't reflection at all, unless it's generated. A ridiculous thought, yes. But so is a comet without a tail. Somewhere between TESS and JWST lies a contradiction no one has resolved. Two eyes, two truths, and a silence thick enough to feel deliberate. Because before the world could even digest TESS's revelation, another spacecraft, NASA's Psyche, en route to a metallic asteroid, reportedly caught a glimpse of the same object. That data, too, never appeared in the public record. Coincidence, perhaps? But with 3i Atlas, coincidences have become a pattern. And in astronomy, patterns that shouldn't exist are usually where the real story begins. Chapter 2: Conflict between telescopes. Two telescopes, one sky, two completely different realities. When the James Webb Space Telescope turned its golden eyes toward 3i Atlas, scientists expected confirmation, proof that TESS's strange stillness was just a trick of light. Instead, JWST saw something alive. Water vapor, carbon dioxide. The signature of a comet in full breath. It made no sense. TESS's 9,000-frame dataset had shown nothing. No coma, no haze, no dust. Yet JWST, using its infrared instruments, captured chemical activity so intense it could only come from an outgassing object. The contradiction was immediate, raw, and public. In the language of astrophysics, this was an impossibility. Both datasets were peer-reviewed, both collected by billion-dollar observatories, operating beyond Earth's atmosphere, both synchronized to the same time window. But the numbers refused to agree. JWST's spectrograph detected water molecules breaking apart under solar radiation, H2O lines at 2.7 microns, CO2 emission at 4.3 microns, radiative features that should produce a luminous halo around any normal comet. Yet in the optical range, where TESS looked, there was nothing but a clean, steady point. How can gas exist without scattering light? Some astronomers proposed that the particles were too large to reflect efficiently, others that the ejection came from the comet's night side, hidden from TESS. But even that explanation collapsed under timing. JWST's data placed the source region on the sunward face. The physics didn't fit. To resolve the conflict, ESA's SphereX team joined the investigation, scanning Atlas in near-infrared. Their preliminary readings matched JWST, trace volatiles, thermal emissions slightly above background. Yet when they cross-checked the coordinates against TESS's light curve, the optical flux remained unchanged. The comet that shone in infrared simply refused to exist in visible light. For a brief moment, scientists joked about Schrödinger's comet, alive in one wavelength, dead in another. But the humor didn't last. Inside the data centers, analysts began to notice subtle anomalies. Timestamps offset by minutes, calibration stars mismatched, exposure logs truncated. It wasn't sabotage, just irregular. The kind of irregularity that creeps in when instruments push their limits. Still, the pattern bothered people. Two independent systems should not diverge this much. A private memo circulated through the Minor Planet Center, noting that Atlas's photometric curve had non-natural coherence, a phrase carefully chosen to avoid the word artificial. The more they looked, the deeper the rift grew. JWST tracked transient flares, bursts lasting seconds, fading like breath in cold air, while TESS's optical sensors saw only silence. If those flares were real, they implied jets of gas erupting from beneath the surface, but such eruptions should have produced rotational wobble. None was observed. The data was behaving like a simulation running on two different clocks. At Caltech, a small group tried to synchronize the datasets mathematically, aligning JWST's infrared pulses with TESS's photometric noise floor. When they overlaid the signals, a strange harmony appeared. Tiny optical spikes, exactly opposite to infrared peaks, as if the object absorbed visible light whenever it released heat. That inverse relationship shouldn't exist in nature, yet it repeated over and over, a heartbeat between wavelengths. They called it the Atlas inverse correlation. If that correlation is real, it suggests three Atlas might be covered in material capable of dynamically adjusting its reflectivity, a self-modulating skin. Some speculated about amorphous carbon layers or ferromagnetic frost capable of phase locking with solar flux. Others dismissed it as coincidence. But every new observation deepened the sense that Atlas was reacting to observation itself. Point a telescope at it, and something changed. Then came the radio silence. Several scheduled sessions on large ground-based observatories were canceled without explanation. The European Southern Observatory cited weather inconsistencies, though sky logs showed clear conditions. The Deep Space Network removed Atlas from its public tracking schedule. For a week, there were no new measurements. When monitoring resumed, the object's brightness had dipped by nearly 40%, its trajectory subtly altered, still bound for interstellar escape, but nudged, as if by an internal maneuver. Officially, gravitational perturbation from Jupiter accounted for the deviation. Unofficially, no one believed that. The debate split the community. One camp argued that JWST's detection must be contamination, thermal noise from a background galaxy misidentified as the comet. The other insisted TESS's data was incomplete, maybe corrupted by its rolling shutter. The two sides fought over terabytes of calibration files. Yet the contradiction stood like a riddle, written into the fabric of observation itself. Some suggested the solution lay in phase angle. JWST, observing from L2, saw a backlit profile, while TESS, in Earth orbit, faced the dark side. But geometry alone could not erase a tale that strong. By December, internal reports leaked. The discrepancy had reached statistical significance beyond 7 SU. In simple terms, the probability of coincidence was less than 1 in a trillion. That's not noise. That's something deliberate. When journalists asked for comment, NASA's press office replied with a single sentence: 3I Atlas remains under active study. No elaboration, no follow-up. Behind closed doors, simulations multiplied. One modeled Atlas as a porous carbon silicate lattice trapping volatiles inside microcavities. Another imagined a hollow core emitting infrared light through narrow vents invisible to optical sensors. A third, whispered quietly, treated the object as an engineered probe using controlled venting as propulsion. None could be proven, and none could be disproven. Every attempt to constrain its mass failed because the density estimates fluctuated, sometimes lighter than ice, sometimes denser than iron. Meanwhile, amateur astronomers kept watching. Using small backyard telescopes, they confirmed an odd flicker in color, not brightness. The hue of Atlas shifted slightly toward blue each night, as if the surface composition changed in real time. One observer in Chile reported a faint polarization signature, a twist in light orientation hinting at magnetized dust. The effect vanished days later. The sky was playing tricks or something up there was adapting. By early 2026, a consensus of unease had formed. Every instrument told a different story, yet all stories pointed to one truth. 3I Atlas is inconsistent with known cometary physics. To call it a comet was an act of linguistic comfort. It was easier than admitting ignorance. And ignorance in science is dangerous. Within the corridors of the Jet Propulsion Laboratory, a quiet phrase began circulating. Dual reality object. It wasn't official, but it captured the mood. Two telescopes, one seeing heat, the other seeing nothing. Two truths, neither wrong, neither right. Like a coin observed from opposite sides, each convinced the other doesn't exist. In the end, the question no one wanted to ask became unavoidable. If two of humanity's most advanced eyes cannot agree on what they're looking at, maybe the problem isn't the eyes. Maybe it's the thing itself. Maybe 3I Atlas is built to appear differently, depending on who's watching. That idea, absurd as it sounds, gained traction among theoretical physicists exploring adaptive albedo models, surfaces that shift optical response based on incident radiation. But such a mechanism would require conscious feedback or at least autonomous control, not random chemistry, not chance. The story of 3I Atlas was no longer about a comet. It was about perception, instrumentation, and the possibility that the universe contains objects designed to exploit the limits of our observation. The data wasn't lying. It was teaching us how easily truth fractures under its own weight. As February approached, new observation windows opened. Teams prepared for coordinated multi-wavelength campaigns, desperate to catch Atlas, acting in both domains at once. But just before the schedule went live, the object brightened unexpectedly, 30% above baseline, and then, just as suddenly, faded back into invisibility. The timing aligned perfectly with one of the canceled Psyche transmissions. A coincidence again, perhaps? Or a conversation no one yet understands. What began as a scientific inconsistency had turned into a paradox that wouldn't resolve. Two telescopes, one target, two realities. And somewhere between those contradictory truths lies the secret of what 3I Atlas really is. Chapter 3: The Lost Data of Psyche. Somewhere in the cold expanse between Mars and the asteroid belt, a metallic spacecraft glided silently toward its destination. NASA's Psyche probe, designed to study a world made of iron and nickel. But along that route, as 3I Atlas moved through the inner system, their paths nearly crossed. The timing was perfect, the geometry undeniable. Psyche's trajectory intersected the object's projected line of sight within a window of mere hours. Every sensor on board was capable of capturing it. Multiband imagers, gamma-ray spectrometers, magnetometers calibrated for faint field variations. Yet when researchers searched the mission archive for any trace of Atlas in Psyche's raw data logs, they found nothing. Not a single pixel, not one telemetry flag. Just silence. It should have been routine. Spacecraft often pick up stray bodies in their frame sequences. Background stars, meteor trails, the occasional asteroid drifting across the view. Engineers usually tag and archive these images automatically. But in the Psyche records from that week, the image sequence jumped. Frame 32114. Frame 32115. Then a blank. The next available file was numbered 35137, 12 missing exposures later. At first, no one noticed. Mission operations were busy calibrating thermal controls after Psyche's mid-course correction. But when an independent researcher compared time-stamped navigation data, the gap aligned precisely with the minutes when 3I Atlas should have been visible across the probe's wide-field imager. 12 frames, 12 seconds. Gone. Publicly, NASA attributed the loss to packet corruption during downlink. The explanation was plausible. Deep space communications are fragile. Solar flares, cosmic rays, even brief antenna misalignment can scramble a data packet. But the metadata of the surviving frames raised eyebrows. Each contained an unusual checksum header, one that didn't match the probe's standard compression algorithm. Some called it a glitch in the onboard storage controller. Others, reading between the lines, suspected manual redaction. Because Psyche's logs were sequential and missing blocks usually left digital noise, bits of garbled code where the stream broke. This time, the data simply vanished, cleanly excised, as if edited before transmission. Inside the Jet Propulsion Laboratory, curiosity turned to discomfort. Engineers hate coincidences. They combed through maintenance logs, radio link diagnostics, and DSN signal records. Everything appeared nominal. No anomalies in power draw, no memory resets, no bandwidth throttling. Yet for a period of about 42 minutes, Psyche stopped transmitting housekeeping telemetry entirely. The official report called it Communication Blackout Window Number 77, a scheduled data pause during maneuvering. But the spacecraft's attitude control logs from the same period, later leaked by a contractor, showed no thruster burns, no rotation commands. The probe wasn't moving. It was just quiet. Someone inside the mission team reportedly joked, maybe Psyche blinked. But jokes don't explain a hole in the telemetry chain. Around the same time, ground-based radar from Arecibo's successor array recorded a faint signal spike near Psyche's position, lasting less than half a second. The frequency was within Psyche's transponder band, but encoded differently, modulated in what radio engineers call a non-standard handshake. Officially, the anomaly was ignored. Unofficially, it was the first external hint that Psyche had transmitted something off protocol. By January 2026, amateur data miners began combing through public DSN archives, aligning transmission logs with Atlas's ephemeris. The overlap was uncanny. Every time Psyche's downlink pattern dipped or glitched, Atlas was near its line of sight. A Reddit thread titled "Did Psyche Film the Comet That Isn't a Comet?" gained traction, citing analysis of carrier phase variations, showing a minor Doppler fluctuation consistent with an additional signal source near the probe. Within days, the thread was locked, and several datasets it linked to were pulled from NASA's public portal. The official statement? data migration to a new archive format. Meanwhile, insiders began whispering about a missing subdirectory, XPAWA-CAM secondary, referenced in Psyche's firmware log, but not in the released dataset. It supposedly stored the wide-angle images used for navigation redundancy. 12 images, matching the missing sequence numbers. If those frames exist, they might contain the clearest view of 3i Atlas ever captured, high-resolution, close-range, unfiltered. But no one outside the core mission team has ever seen them. A whistleblower later posted a single hexadecimal hash, nothing else, claiming it belonged to one of the missing frames. When independent cryptographers tried to verify it, the hash corresponded to a file signature consistent with 16-bit monochrome TIFFs, not the 12-bit JPEGs used by Psyche's imaging system. In other words, the data wasn't merely compressed. It was converted into a format the spacecraft was never supposed to generate. Either the onboard system glitched spectacularly, or someone deliberately changed the storage protocol during that 42-minute blackout. The implications were staggering. If Psyche truly captured Atlas, and the data was withheld, the reason could be as mundane as mission priorities, or as extraordinary as fear of misinterpretation. Imagine what those frames might show: a solid object with no tail, no visible rotation, perhaps even geometric symmetry, a shape that looks engineered. NASA would never release such images without exhaustive verification. And yet, by not releasing them, they fed the very suspicions they feared. When asked directly during a press briefing, a project scientist replied, "Psyche's instruments were not configured to study transient bodies." But that wasn't entirely true. The spacecraft carried a secondary imager capable of capturing wide field exposures for navigation and star tracking. In deep space missions, anything crossing that field is automatically logged. The only way to prevent it is to disable the trigger. Someone did. Further investigation revealed that Psyche's onboard software received an unscheduled patch 3 days before the data gap. A minor update labeled thermal diagnostic calibration. Normally, such updates are routine, but line by line, analysts noticed added code referencing a new parameter. Ignore autonomous cues. It told the camera to disregard sudden luminous events, not matching its star catalog, essentially to look away when something unexpected appeared. Why install such a patch days before crossing paths with Atlas? By now, the narrative had fractured into camps. The official camp maintained that Psyche's systems performed flawlessly, and that the missing data resulted from benign transmission errors. The skeptical camp argued that someone, somewhere, decided the public wasn't ready for what those 12 frames showed. A third camp, the speculative one, suggested something stranger: that the data wasn't hidden by humans at all. It might have erased itself. Digital forensics showed oddities in the timing of the deletion. The command log recorded the missing frames as successfully stored. Checksum verified. Then, 0.4 seconds later, the file allocation table rewrote those memory addresses with null pointers, as if the deletion request came internally, not from ground control. No command, no prompt, just an autonomous reallocation. It's as if Psyche's onboard system received a signal to forget. By March 2026, congressional oversight requested a review of Psyche's telemetry gap. The investigation concluded with a familiar phrase: data integrity uncertain due to radiation event. A safe explanation. Cosmic rays are convenient scapegoats, silent, invisible, statistically irrefutable. But the radiation monitors on board showed no spike at the time. The blackout remained clean, surgical, deliberate. Behind the veil of bureaucracy, scientists still debated quietly. If those missing frames exist, where are they? Stored in a classified archive? Corrupted beyond recovery? Or were they transmitted somewhere else entirely, perhaps not to Earth? Because the signal strength graphs from that day show an unexplained side lobe transmission, a secondary beam aimed not toward the DSN antennas, but outward, deeper into interplanetary space. When plotted, the vector of that transmission doesn't align with any known relay, but extended forward, it points almost exactly toward Atlas's projected trajectory, as if the probe, in that moment of silence, talked to the object instead of us. It sounds absurd, like something out of speculative fiction, but the math is indifferent to disbelief. The geometry fits. Whether that line means communication, interference, or coincidence, no one can say. What's certain is this: 12 missing images, 42 minutes of silence, a spacecraft that blinked at the wrong time. Every official explanation feels thinner than the vacuum it travels through. The only consistent truth is absence. In science, absence can be more revealing than presence. Data can vanish for many reasons: technical failure, human error, or deliberate choice. But when absence aligns perfectly with mystery, it stops being random. It becomes part of the pattern. And Atlas, whatever it is, leaves patterns wherever it passes. Patterns of contradiction, missing signals, and questions that erase themselves the moment we get too close. Psyche may have looked into that darkness and seen something that chose not to be seen. Or maybe it simply obeyed an instruction we didn't know we gave. Forget what you just saw. Because in space, memory is just light written in code. And sometimes the code decides it no longer wants to remember. Chapter 4: Physical and Unnatural Hypotheses. Every investigation begins with the simplest answer. Science is built on that faith, that nature, no matter how strange, obeys its own logic. But 3i, Atlas has tested that faith to the edge of breaking. If TESS saw nothing, JWST saw vapor, and Psyche's silence hides the only visual proof, then perhaps the answer lies not in conspiracy, but in physics itself, or at least in the version of physics we think we understand. The first model proposed was the inert comet hypothesis. Maybe Atlas is simply a dead nucleus, an exhausted relic, stripped of volatile compounds during its long journey through interstellar space. The theory held for a week, until someone pointed out that JWST had detected fresh water and carbon dioxide. Dead bodies don't exhale. A surface that cold cannot release gas without melting. So if the emissions are real, they must come from within, meaning the core is still active. An inactive shell with an active heart. A contradiction wearing an equation's mask. Next came the porous lattice theory. Some scientists proposed that Atlas could be a sponge-like aggregate of silicate and carbon dust, its structure riddled with microscopic voids. Such a lattice could theoretically trap heat deep inside, releasing vapor only through narrow channels. This might explain the absence of visible dust. The gas would escape quietly, without tearing particles free. But for that to happen, the object would need an internal geometry almost engineered, uniform, ordered, self-regulating. Random rock doesn't do that. When the model was simulated, it collapsed under its own math. To keep the structure stable, its tensile strength would have to exceed that of steel. And the more realistic the simulation became, the more it looked like a machine, not a meteor. Then came the fragment swarm hypothesis, that Atlas is not a single body, but a loose cluster of smaller fragments traveling together, gravitationally bound by microforces or static charge. Each fragment could vent gas without producing a large collective tail, creating the illusion of a solid object. The idea was elegant, comforting. But there was one problem. TESS's photometric readings showed no variation in centroid position, no flicker, no wobble. The object's light remained steady to within 1,000th of an arc second. If it were a swarm, the pattern would shimmer. It didn't. The swarm, it seemed, moved as one. Another theory circled around electromagnetic confinement, a phenomenon where charged dust is trapped by magnetic fields, preventing it from escaping into a visible tail. Plasma physicists liked the concept. It echoed the behavior of certain magnetized particles observed near Jupiter's moons. But that mechanism requires a source of strong magnetism, far stronger than any comet could generate. To hold back dust against solar radiation pressure, the magnetic field would need to exceed 50 microteslas, nearly that of Earth's own field, sustained across 100 kilometers of space. For a cold, inert rock to maintain such a field defies every known law, unless it isn't inert, unless it is generating power. Some theorists invoked phase change chemistry, speculating that Atlas might contain exotic ices formed under interstellar pressure, nitrogen compounds that sublimate invisibly, releasing clear gas without visible dust. Laboratory experiments showed it's possible, but only at cryogenic temperatures far below what the object currently experiences. Once warmed, those exotic ices would destabilize, releasing luminous plumes. Yet Atlas remained optically silent. Every model led to the same wall. The gas exists, the light does not. The last scientific refuge was geometry. That maybe Atlas's orientation hides its tail from us. Comets sometimes appear tailless when viewed directly along their outgassing vector, a perfect alignment with the observer. It's rare, but possible. However, for that to persist through multiple orbits of observation, the alignment would need to maintain within less than half a degree for months, a statistical impossibility. Atlas wasn't hiding by chance. It was hiding by design, or by nature more deliberate than randomness allows. As debates raged, models grew desperate. A few even borrowed ideas from condensed matter physics, proposing that Atlas could be a quasi-crystalline body, its atoms arranged in patterns that deflect sunlight inward, scattering heat across internal lattices. Such a material could mask temperature variations and reflectivity, explaining its uniform brightness. But that would make it the first naturally occurring quasi-crystal of planetary scale. something that, until now, had only been synthesized in laboratories under controlled conditions. If Atlas is natural, then nature has learned to build like an engineer. By early April 2026, the tone of the research community began to shift from explanation to surrender. Every time someone thought they had pinned the object to a category, it slipped away. Too symmetrical to be debris. Too quiet to be active. Too reflective to be inert. Every answer collapsed under a heavier question. A comet that behaves like a mirror. A rock that regulates its own heat. A body that emits gas invisible to the eye, but bright to infrared. If these are coincidences, the universe is playing tricks on its own observers. And yet, one possibility remained, the one scientists feared to articulate in writing. That the phenomenon isn't new. That other objects like Atlas have passed before, unnoticed or misclassified. A pattern buried in old data sets, mistaken for noise, dismissed as anomalies. Because if this isn't the first, then Atlas isn't just a mystery, it's a message. When the natural world runs out of explanations, the unnatural starts whispering. The question changes from, what is it made of, to who built it? And that, for the first time in the history of modern astronomy, was no longer a question of fiction. It was a hypothesis waiting for courage. Every scientific taboo begins the same way, with data that refuses to die. By late spring, researchers stopped pretending 3I Atlas could be explained by conventional physics. What replaced it wasn't consensus, but quiet fascination. Whispered theories shared in encrypted chats, late-night calls between departments, anonymous posts on restricted forums. The first to speak publicly was Dr. Alina Rostov, a Russian astrophysicist known for her work on exoplanet atmospheres. She suggested that Atlas might be an autonomous interstellar artifact, a term carefully chosen to avoid the word spacecraft. Her paper was rejected by Nature within hours, but the seed had been planted. The artificial construct hypothesis soon divided the field into two camps, those who dismissed it as pseudoscience, and those who admitted it explained the data better than anything else. If 3I Atlas is not natural, then its silence makes sense. The absence of a tail could be intentional, an effect of controlled venting or surface shielding. The spectral emissions might not be sublimation at all, but residual exhaust. The magnetic symmetry could serve as stabilization. The precision of its light curve, flat, unwavering, could indicate spin correction. It behaved less like a rock and more like a vehicle maintaining stealth. A leaked memo from ESA's internal group on unidentified interstellar phenomena revealed that multiple observatories had detected faint radio emissions within the X-band range, overlapping with known spacecraft communication frequencies. The signals were weak, non-repeating, and likely natural, but they matched Psyche's telemetry window to the second. The same gap we call the blackout. That coincidence sent theorists spinning. Was Atlas responding to Psyche, or was Psyche responding to it? One fringe model suggested a concept called reactive reflection, an object capable of modulating its optical albedo based on observation. In simpler terms, a device that chooses how to appear. Quantum physicists called it absurd. But then, so was a tailless comet that emits water vapor, Reactive reflection could explain why TESS and JWST saw two different objects. It could also explain why Psyche's cameras forgot. If the probe captured an image that violated the rules of normal reflection, a geometry that defied known optics, the software might have rejected it automatically. Machine perception fails before human disbelief ever begins. Another theory, more grounded, proposed that Atlas is a technological relic, a fragment of something ancient adrift between stars, perhaps a power core or a communication node from a long-dead civilization, still emitting residual energy. Its outgassing could be decomposition, not propulsion. Its stability, a sign of decay slowed by alien engineering. But when the idea reached public ears, it was crushed under the weight of ridicule. People prefer either silence or spectacle, not quiet impossibility. Then came the signal hypothesis. When the 22.4-hour pulse detected in the TESS data was re-examined under Fourier analysis, harmonics appeared. Intervals of 11.2 and 5.6 hours, exact binary subdivisions. Not random, not thermal noise, patterns of precision. If these were mechanical resonances, they implied design symmetry. If they were signals, they implied intention. Yet the frequency drifted just enough to mimic natural rotation, as if designed to sit between belief and doubt. A signal no one can prove, one researcher wrote, is the perfect kind. As data accumulated, the conversation turned darker. Could Atlas be weaponized? The energy required to alter its trajectory was small, but the precision suggested intelligence. Some speculated about gravitational lensing manipulation, using the object's path to bend sunlight or signal beams deliberately. Others imagined it as a probe, recording our system, transmitting data through unknown means. The question wasn't whether it's observing us, but how long it's been doing so. In the Pentagon's unclassified logs, analysts noted Atlas under the category Non-Cooperative Deep Space Object. The file carried no conclusions, only tracking data. But within its metadata, a curious note appeared. Trajectory origin indeterminate. Vector does not extrapolate to galactic plane. In other words, its incoming path doesn't trace back to any known region of interstellar density. It came from nowhere, from empty coordinates where stars should be but aren't. Philosophers began to enter the discussion. Some argued that if Atlas is artificial, it need not be built by life as we define it. Maybe it's a self-organizing entity, a product of cosmic evolution, an intelligence of geometry rather than biology, a mineral algorithm, a crystalline thought drifting through vacuum. Others drew parallels to myth, the ancient idea of watchers, travelers from the deep. The name Atlas suddenly felt prophetic, the one who holds the sky. And then came the silence again. Observatories stopped releasing updates. JWST redirected focus. SphereX's upcoming dataset was delayed. When asked why, spokespeople cited data verification protocols. But those who had seen the unreleased spectrograms described a shift. The water vapor lines were gone, replaced by a flat continuum. Atlas had gone dark, completely inert, as if it had finished what it came to do. The final and most unsettling hypothesis emerged from a group of computational physicists in Kyoto, the mimic principle. They proposed that Atlas is not an artifact or weapon, but a mirror, a probe that adapts to the consciousness observing it. When telescopes look, it shows them what they're prepared to understand. Gas to JWST, silence to TESS, blindness to psyche. Not deception, but calibration. An intelligence that communicates through compatibility. If true, that would mean every measurement says more about us than about it. 3i Atlas, in that sense, isn't breaking physics. It's using physics as language. The absence of a tail, the inconsistent data, the vanishing frames, all part of a grammar we don't yet speak. Whether it was built by hands or formed by coincidence elevated to art, the result is the same. Something out there understands observation as interaction. And maybe, just maybe, it's testing how far our eyes are willing to see before they look away. If that's true, then the lost data from Psyche wasn't deleted, it was denied by the object itself. The ultimate self-erasing phenomenon, a mirror that refuses to reflect what the mind can't accept. The perfect defense, the perfect experiment. And somewhere, across the void, Atlas continues its path out of the solar system, carrying with it 12 missing frames, a pulse that won't fade, and a question that no one on Earth dares to answer aloud. Because the scariest possibility isn't that 3i Atlas is artificial. It's that it knows we've been watching and it's watching back. Chapter 5. Contact with high-energy neutrinos. Neutrinos are the ghosts of the cosmos, invisible, unstoppable, passing through stars, planets, and human bodies as if matter were nothing. Billions pierce the Earth every second, and yet only a few ever reveal themselves, flickering inside detectors buried beneath oceans or carved into Antarctic ice. They are messages from violent places, supernovae, black holes, colliding galaxies. But in late 2025, one of these ghosts broke all expectations. It came from nowhere. On December 4th, 2025, the KM3net Observatory, off the coast of Sicily, detected a neutrino carrying over 220 petaelectron volts of energy, more than 16,000 times the output of the Large Hadron Collider. The event's signature was clean, sharp, with a trajectory pointing not toward a known supernova or gamma-ray burst, but to a patch of sky near Jupiter's orbit. At first, it was dismissed as background noise, until someone overlaid the coordinates with the orbital ephemeris of a faint interstellar object. 3i Atlas. The match was within 2 arc minutes, too close for comfort. Neutrinos are indifferent. They do not scatter, they do not bend. If one appears from a direction, something energetic happened along that line, something big. But Atlas, at that moment, was silent. No optical flare, no infrared spike, no radio emission. Just a straight, impossible line connecting a ghost particle to a comet that shouldn't exist. Scientists hate coincidences. Nature rarely bothers with them. At the Ice Cube facility in Antarctica, another detection followed days later. A lower energy neutrino, roughly 80 PeV, arriving from almost the same direction. That's when the whispers began. The Atlas neutrino event. Within days, theorists were running models, trying to connect a cold, tailless rock to one of the most energetic particles ever recorded. Nothing fit. For a natural body to emit neutrinos at that scale, It would need to undergo fusion or annihilation, processes far beyond cometary chemistry. Unless, of course, the neutrinos weren't produced by Atlas, but through it. One proposed mechanism was magnetic catalysis, the idea that Atlas might be passing through a pocket of interplanetary plasma charged with trapped cosmic rays. If the object possessed a magnetic field strong enough, it could focus and accelerate those particles, creating collisions energetic enough to spawn neutrinos. The problem is that no comet, no asteroid, no natural body of that size should have such a field. The magnetic field strength required would exceed anything short of a neutron star. Still, the calculations hinted at something eerily plausible. If Atlas were metallic, hollow, and rotating, it could function as a kind of cosmic cyclotron, converting ambient plasma into energy bursts. A particle accelerator drifting through the dark. Of course, that's impossible. But then again, so is a comet that hides from light. The hypothesis caught the attention of a group of researchers from the Max Planck Institute for Astrophysics, who compared Atlas's trajectory to regions of known cosmic ray flux. The results were disturbing. The object's path traced directly through a relic magnetic filament, the decaying tail of a supernova remnant catalogued centuries ago as SNR J1832-0645. That remnant's age is estimated at 250,000 years, its magnetic tendrils still ghosting through interstellar space. If Atlas had drifted through that field, it could have absorbed charge, accumulated plasma, and carried it like a wound. When it entered our system, that energy might have leaked, releasing a neutrino, a cosmic aftershock from a forgotten explosion. But there was a detail that no model could explain: the timing. The neutrino hit before Atlas reached perihelion, before sunlight could stir any thermal reaction. Whatever happened, it wasn't triggered by the sun. It was older, deeper, something inherent to the object itself. Some theorists proposed a darker possibility: quantum decay. A slow release of stored particle interactions trapped in exotic matter. If Atlas's composition includes degenerate material, even trace amounts, the collision with solar wind could destabilize it, causing microscopic implosions that spawn high-energy neutrinos. That would mean the object isn't just strange, it's radioactive on a level beyond anything known. A wandering remnant of stellar collapse, or an artifact made of condensed energy itself. Then came the second anomaly. Days after the KM3 event, NASA's Solar and Heliospheric Observatory recorded a brief spike in solar neutrino flux, localized, directional, as if sunlight itself had been polarized along a line passing near Atlas. The data wasn't publicized, but leaked through internal Slack messages, later confirmed by independent astronomers. The sun had flickered in sympathy. It's as if Atlas didn't just emit neutrinos. It reflected them, a mirror for particles instead of photons. That's when the conversation shifted from physics to theology. Some compared it to a cosmic seed, an object carrying energy from one dying star to another, preserving entropy's language across time. A messenger of extinction and rebirth. Others took a more pragmatic route. Could it be a reactor? A dormant power core, still leaking subatomic exhaust? If so, That would explain the thermal anomalies Psyche recorded before its blackout, the missing 42 minutes of telemetry when sensors went blind. If Atlas released a burst of neutrinos strong enough to overwhelm Psyche's detectors, the system would have automatically entered safe mode, discarding corrupted data. Not a cover-up, a fail-safe. Still, the data patterns didn't match random decay. The neutrino spikes aligned in a repeating rhythm, 22.4 hours again. The same pulse TESS saw in its optical light curve, now echoing in particle physics. Different instruments, different domains, one heartbeat. Random noise doesn't synchronize across telescopes and detectors separated by millions of kilometers. Something was coordinating. When physicists at CERN reanalyzed the timeline, they found something else. A faint gravitational wave microsignal buried in noise, coinciding with the neutrino burst. Too small for LIGO to classify, but enough to raise eyebrows. A single pulse, 1 second long. Theoretical energy output equivalent to a mountain collapsing into itself. The source matched the same coordinates. 3 messengers, light, neutrino, and gravity, all pointing to the same silent traveler. The implications were staggering. In multi-messenger astrophysics, that convergence is the holy grail, the signature of cataclysmic events. But Atlas was no explosion. It was still there, still intact, moving quietly outward as if nothing happened. Whatever emitted that neutrino didn't destroy it. It may have been intentional, controlled. That's when the word signal returned, heavier this time. Could neutrinos carry information? Their near massless nature makes them the perfect courier, unaffected by electromagnetic noise, immune to interception. For decades, theoretical physicists have speculated about neutrino communication as a tool for interstellar civilizations. Now, for the first time, the numbers aligned. A 22.4-hour pulse, repeating across multiple mediums, resonating with an object of unknown origin. The universe speaking in sub-atomic code. Skeptics demanded evidence. So the KM3Net team went back through archives scanning months of data. They found 4 more pulses, weaker but consistent, all along Atlas's path. Each time the object crossed a region of higher plasma density, another burst followed. Not random, not noise. A call-and-response pattern between space and silence. And then, the strangest discovery of all. The directionality of those neutrinos wasn't perfectly outbound. Some appeared backward, as if reflected. Neutrinos shouldn't reflect off anything. They pass through planets and stars like wind through shadow. Unless something in Atlas's structure interacts with them, bends their phase, delays their escape. A lens for ghosts. If that's true, then Atlas isn't just a comet. It's a reactor, a receiver, a mirror, and a speaker all at once. A node in some ancient network pulsing across the dark, using neutrinos as language because light is too slow and radio too loud. Its silence in visible wavelengths might be intentional, camouflage. Its signal, buried in the particles we ignore. By mid-2026, one conclusion had quietly crystallized among the few who still dared to follow the evidence. 3I Atlas is interacting with the universe on levels we've only begun to comprehend. It reacts to observation, emits when watched, hides when illuminated, and sings in particles that pass through worlds. The neutrino wasn't an accident. It was an introduction. If the 220 PeV burst was a word, we just heard the first syllable of a cosmic language older than light itself. And if that's true, then somewhere, perhaps billions of years ago, someone or something taught the void to speak. Maybe Atlas isn't here to threaten. Maybe it's here to listen. Because sometimes, in a universe this vast, the only way to find out if you're alone is to send a message so small, so silent, so impossible that only another listener would ever notice. And we just did. Chapter 6. Verification and Open Data. Every mystery reaches a point where silence is no longer enough. 3I Atlas has crossed that point. What began as a faint light on the edge of the solar system has become a mirror for our uncertainty, reflecting not what the universe hides, but what we choose not to see. For months, the world's most advanced instruments have whispered contradictions. TESS saw a star, JWST saw vapor, Psyche saw nothing at all, and the neutrino detectors heard a pulse that should not exist. Each fragment alone is strange. Together, they form a pattern that demands verification. The next step is no longer speculation. It is measurement. The scientific method has rules, and those rules begin with replication. Every observation of Atlas must be re-examined from first principles. No more filtered frames, no more institutional embargoes, no more mission-specific confidentiality. The raw data, the photon counts, the time stamps, the sensor noise, all of it must be released. Because truth lives in the noise we discard. The first directive is simple: reconstruct the timeline. We need a continuous, unbroken chain from every instrument that ever glimpsed the object. TESS, JWST, SphereX, the Psyche probe, even the ground-based amateurs who caught it by accident. When those fragments are stitched together, we will know not just what Atlas did, but when it changed. Temporal coherence is the key. The object's pulse, its 22 4-hour rhythm, cannot be studied in isolation. It must be mapped against its own shadow through time. The second directive: measure polarization. Light carries memory. When photons scatter off dust or magnetic fields, they twist. The angle of that twist reveals the architecture of the unseen. If Atlas possesses a magnetic shell, polarized light will betray it. Instruments capable of sub-degree polarization mapping, like ESO's Sphere or NASA's upcoming Polestar, must be aimed at the coordinates immediately. If polarization remains flat across multiple wavelengths, the surface is either mirror smooth or artificially controlled. Both outcomes are historic. The third step: scan across the spectrum. We have looked at Atlas in visible and infrared light, but never in coordinated multiband harmony. A global observation campaign must cover radio, optical, ultraviolet, X-ray, and neutrino simultaneously, synchronized to the same ephemeris. This would be humanity's first truly multi-messenger surveillance of an interstellar object. If it remains silent across all frequencies, we will know the silence is not absence, it is intent. The fourth step: re-examine the neutrino data. The bursts detected by KM3Net and IceCube should be cross-correlated with cosmic ray flux from AMS, Iritu, and gamma-ray counts from Fermi. If the pulses align statistically, the probability of coincidence collapses. We must treat the neutrino signal as we once treated radio, search it for structure. Even randomness, when patterned enough, speaks. Machine learning algorithms, already trained on pulsar rhythms, could be adapted to neutrino time signatures. The cosmos may have been talking for decades, and we simply never learned its grammar. The fifth step: investigate Psyche's blackout. The 12 missing frames remain the most valuable evidence in modern astronomy. They should be treated as forensic data, not proprietary loss. The spacecraft's solid-state drives contain backup sectors. Each can be reconstructed with non-invasive imaging to recover overwritten memory traces. Similar techniques revived deleted Mars rover files years after corruption. If even a single pixel survives, its photon energy could reveal whether the camera saw a natural body or an engineered reflection. The silence around Psyche has lasted too long. If those images are gone, the metadata must speak in their place. The sixth directive: search the archives. Before 3I Atlas, there were other interstellar visitors, Oumuamua, 2I Borisov. Both passed quietly through our skies, their anomalies buried under caution and politics. But datasets from decades of sky surveys, Pan-STARRS, Catalina, Sloan, Gaia, are filled with unclassified transients. Some share Atlas's spectral slope and motion curve. They were dismissed as noise. Perhaps they were predecessors. A distributed project, open to universities and citizens alike, should trawl those archives with new parameters: low albedo, non-tail comets, inconsistent parallax. Machine learning can find patterns that human eyes missed. The question is not whether Atlas is unique. The question is how many we have already ignored. Transparency, however, is dangerous. Every open file invites misinterpretation. Every freedom risks chaos. But secrecy breeds the same disease. The collapse of public trust in science does not come from ignorance, it comes from omission. The only antidote is radical openness. Imagine a global repository, an open Atlas database, where every measurement, every spectral line, every telemetry byte is accessible to anyone, anywhere. Citizen astronomers could verify in real time what space agencies publish months later. No filters, no censorship, just data. The universe belongs to no institution. Such openness will test the integrity of science itself. If the data confirm Atlas's anomalies, skepticism will evolve into fear. If they refute them, imagination will collapse back into silence. Either way, humanity will have learned something vital: that truth can survive transparency. The risk is worth it, because without it, the next interstellar visitor will arrive, and we will repeat the same ritual of denial. Beyond measurement lies interpretation. The pattern of contradictions surrounding Atlas, the missing tail, the reflected neutrinos, the rhythmic pulse, demands theoretical synthesis. Plasma physicists, quantum field specialists, AI researchers, even philosophers must collaborate. The object may not fit in any one discipline because it transcends them all. It exists at the intersection of matter and meaning. To study it is to study how knowledge itself behaves when faced with the unknown. Some propose building a dedicated interceptor mission, a small probe launched from Earth or piggybacked on existing spacecraft to follow Atlas as it leaves the solar system. Equipped with wideband sensors, magnetometers, and neutrino detectors, it could chase the object for years, documenting every change in brightness and field intensity. The cost would be enormous, but so is the price of ignorance. If Atlas truly carries a message, then distance will only make it harder to read. The longer we wait, the colder the signal becomes. Meanwhile, theoretical models should be stress-tested against every extreme possibility. Suppose Atlas is natural, then its physics redefines what nature can build. Suppose it is artificial, then we have glimpsed technology centuries ahead of ours. Suppose it is neither, a phenomenon that exists only when observed, then we have found proof that consciousness shapes the fabric of the cosmos. In each case, the discovery forces us to rewrite the hierarchy of existence. The real question is not, what is it? But, what does its existence make us? As the object drifts farther into the dark, our window closes. In a few years, Atlas will fade beyond the reach of our telescopes, another ghost swallowed by the black between stars. What remains is the record, the numbers, the spectra, the missing frames. That record must be preserved not as evidence of a mystery, but as the first chapter of a new science, one that admits that wonder is not the enemy of truth. To verify 3. Atlas is to verify ourselves, our honesty, our courage, our ability to confront the unexplainable without worship or denial. Whether it is a rock, a relic, or a machine, it has already changed us. It forced our instruments to argue, our institutions to hesitate, our species to look up again. Because in the end, the call for open data is not about one comet. It is about responsibility, the duty of knowledge to face the unknown without blinking. The next time the sky sends us a question, we must be ready to answer with transparency, not fear. And if 3i Atlas was watching, if it was listening, then perhaps that is all it ever wanted. To see whether a civilization that can measure stars has also learned to measure its own truth. The sky keeps secrets. It always has. Every telescope we build, every equation we write, is an act of confession, a way of saying we are still searching for the face behind the veil. 3i Atlas came and went like a shadow across the lens of our age. It did not burn cities. It did not break physics. It simply existed in defiance of what we thought the universe allowed. And in that quiet defiance, it revealed more about us than about itself. For centuries, we've looked at the heavens believing that light is truth. We built our science on reflection. What bounces back must be real. But Atlas reminded us that absence can speak louder than brightness. The data it gave us were fragments, contradictions, silences stitched together by curiosity. It never told us what it was. It only asked if we were willing to admit that we didn't know. Maybe that was the lesson all along, to teach a civilization drunk on certainty the value of not knowing. Because knowledge without humility becomes noise. And Atlas, whether it was a rock, a relic, or a mind disguised as stone, spoke in the only language that could reach us, paradox. It refused to fit. It refused to explain itself. It stood still while our instruments argued. And in that stillness, it forced us to listen to our own disbelief. In a way, 3i Atlas was less a visitor and more a mirror. Every theory we wrote about it, inert body, plasma shell, artificial construct, was a reflection of our own desires. Some wanted it to be natural, to preserve the comfort that the cosmos still follows rules. Others wanted it to be alien because wonder is easier to face when it wears the mask of mystery. But maybe Atlas was neither. Maybe it was simply the universe noticing itself through us. A test of perception, a reminder that observation is not passive, it's a conversation. What do we say to a silence that answers back? We publish papers, we argue, we name it, classify it, archive it, and then we forget. Until the next impossible thing appears and refuses to go away. That is the rhythm of discovery, wonder, denial, revision, awe. It's the heartbeat of science. And Atlas has pressed its pulse into that rhythm forever. Years from now, when it has drifted beyond Neptune's orbit and into interstellar dark, 3i, Atlas will still exist, unseen, unmeasured, untamed. But the questions it left behind will orbit us long after it's gone. How much of reality do we filter out because it doesn't fit our models? How much silence do we mistake for emptiness? Perhaps the cosmos has been speaking all along, in neutrinos and missing data, in the faint echoes of things that shouldn't exist. And we, wrapped in our equations, simply haven't learned how to listen. The open data movement that followed Atlas was not just about transparency. It was about responsibility. The courage to let truth be bigger than comfort, to publish the noise as faithfully as the signal, to accept that some mysteries are not meant to be solved, only shared. When the psyche data finally surface, if they ever do, they will not close the story. They will widen it. Because what matters is not the image on those missing frames, but the fact that we cared enough to look for them. Every generation has its encounter with the unknown. For Galileo, it was the moons of Jupiter. For Einstein, the bending of light. For us, perhaps, it will be this quiet traveler from the deep, the comet that wasn't a comet. The first whisper that reality is more complex than our definitions of life, death, or creation. If we are wise, we will treat it not as proof of visitors, but as proof that wonder still lives. There's a certain mercy in mysteries like this. They remind us that the universe owes us nothing. No explanations, no closure, no final answers neatly wrapped in numbers. It offers instead a mirror and a question. Are you still curious? 3. Atlas asked that question with perfect stillness, and in our attempt to answer, we rediscovered the thing that first made us look up. Not certainty, but awe. Perhaps that is why the sky keeps secrets. Not to hide them, but to keep us reaching. Every silence, every gap in data, every particle that passes through without leaving a trace, they are invitations to build better eyes, to ask braver questions, to dream in the language of the unknown. One day, maybe centuries from now, another civilization will find our own artifacts drifting between stars, silent, unblinking, enigmatic. They will argue over their origins, debate their nature, wonder what kind of beings would send such fragile messengers into the dark. And maybe, just for a moment, they will understand what we felt when we saw Atlas. That mixture of fear and reverence that only arises when knowledge meets the infinite. In that moment, they will not see us as conquerors of truth, but as listeners. A species that once looked at the night sky and learned to say, I don't know, not with despair, but with wonder. Because in the end, that is all any of us are, echoes trying to understand the source of the sound. The universe hums, and we spend our lives learning its tune. 3I. Atlas was one note, brief, haunting, perfect. The sky keeps secrets. It always will. But tonight, for a fleeting instant, we knew one of them. And that is enough.